So let me give you a rundown of the topic and an overview, and then we'll actually start learning the material for this. So this is what I call structure and bonding. That's where you're probably going to find it when you search on Google and things like that. This is chemistry 2.4, if you guys are looking up the unit, and the AS number is 91164. So if you're looking for any resources tied to it, that's what you want to look up on Google or on NZQA. This one is an external. So that means you take it at the end of your exams, and it is worth 5 credits. So nice, meaty standard there. This standard is a bit of a Frankenstein standard because they've mixed and matched a lot of different chemistry topics together. We still do it though because it gives you a lot of good foundational chemistry information, and it's also the reason why I want to start with it. There are going to be 3 main topics for this standard, or for the exam I should say. The first one is going to be on types of solids. The second question is going to be on Lewis structures, shapes, and polarity. And then the third question you're going to get is on enthalpy calculations. So those are going to be the 3 questions you're going to get. Now, what I'm going to do is I'm not going to teach this whole standard from start to finish. We're going to start and stop this standard because I think it goes best with the teaching. So what we're going to start with is the types of solids, which is what we were doing in that previous activity, classifying our matter into one of 4 categories. We're going to do that one first. After we finish that question, we're going to have a pause, and we're going to actually move on into our internals. And in fact, we're going to do all of our internals before we pick back up this standard. So the reason why I decided to do it that way is because I want us to learn this material closer to the exam, so it's fresh in your mind. The other reason is I need to go through types of solids so you understand the foundation of chemistry before we do anything else. So it's really kind of, like I said, a Frankenstein standard. It doesn't really make sense, so I'm splitting it up into an order that makes sense. Are we okay so far? We good? All right. I have printed off some exam questions so we can actually learn through what is going to be expected for that question. So if you want to have a little look, I've passed out this piece of paper to everybody. It is double-sided. This is something that you can work on tomorrow with Ms. Falasolo. What you will notice that is very frequent in these exams are these tables here. In these tables, they give you a list of different substances, and then they ask you to classify what type of substance it is, what particles make up that substance, and what attractive forces hold everything together. Getting this right is going to be the key to getting this question right, because they use this as kind of like a foundation. And then what you'll notice is in that other bits of the question, they're going to ask you to explain the properties. So explain why metals are conductive. Explain why they are malleable. Explain why ionic solids can dissolve in water. So they're going to ask you about the properties, and when you are trying to explain those properties, you then tie it back to the particle and the attractive forces. So the big thing that you guys have to remember with this question is that if you misclassify the solid and you put it into the wrong category, when you go to write up your long answer justification, it snowballs, and then your justification, where the big points are, you're not going to get any. Are we okay with that so far? All right, so let's talk about classifying. So today's lesson is only focused on how do we figure out what's what. We're not going to worry about justifying their properties and why they have those properties. That's going to be the next couple weeks. We good? All right. So first one that we are thinking about when it comes to our types of solids is going to be our metals. And I should have printed off periodic tables for you guys. Just occurred to me. Metals should be really easy to find because you just need to look at the periodic table and you're looking to see is what they've given me on the metal side of the periodic table. And let me pull up a periodic table to show you what I mean. And unfortunately, I forgot to print off periodic tables, so I will do that next lesson. I'm just trying to find a good one. Here you go. Make that a little bigger. All right, so here's our periodic table. Do you see how we have it categorized into metals, non-metals, and the malanoids, which is kind of like in between the two? So the way I find out whether or not something is a metal is I look at the periodic table. Here is kind of the imaginary line between metals and non-metals, and I look to see is it on that side of the periodic table. So I've given you 2 bits of aluminium. We see aluminium's over here. So that fits in my metal category. The other thing I gave you was silver, and we can see silver is Ag over here. So metal should hopefully be easy to find. Just trying to think if there's any examples of it. So when we are looking at these sort of sheets here, I'm just going to look at 2021, question 1A. You see how they've given us a list here? And I can see that metal is that copper. So I would classify that as my metal. So we're just looking for metal elements. So for the metals, you are looking for metal elements. Now, 2 things that you're going to have to fill in when you're thinking about that table is the particle that makes up a metal and the bond. So particle is going to be atoms. Atoms make up metals, and we'll talk about the structure of that next week. And the other thing is what holds metals together. So if we're looking at our metal substances like the rings and the aluminium and the aluminium can, we're asking why are those atoms sticking together? And those atoms are sticking together because of metallic bonds. So when we're thinking about the bonds, or the forces is what they often refer to that as, it is metallic bonds. So that should be easy to fill in. We good so far? Okay, metal should be obvious. The next one, which is now we're starting to get a little bit, should be able to do this one easily, is the ionic solids. What you are looking for here is you are looking for a combination of a metal element with a non-metal element. So we're looking for a compound. You guys remember compounds from last year? Or do you need me to define it? Do you want me to define compound? Yes or no? Yes? Okay. So compound are 2 or more different, is the key word, elements chemically bonded together. So when we are thinking about an ionic compound, we are thinking about something that has a metal and a non-metal. So again, look at that periodic table, use that periodic table to help figure out what are my 2 elements. I've put out 3 examples there. There was sodium chloride, there was sodium bicarbonate, and then there was also magnesium sulfate, which is our bath salt. Those are the 3 examples we had on the table. If we look at the periodic table, we can figure out what are metals and non-metals. I'm just going to flick it over real quick so we can see it. So we see sodium and magnesium are over here. Chlorine's over there. Hydrogen is over here. Oxygen's over here. Sulfur is over here. So you see how we have a mixture of that pink and blue. So that's what we're looking for our ionic. So we're looking for example, this is a metal, that one's a non-metal. That one's a metal, that one's a metal, that one's a non-metal, that's a non-metal, all over here. Sorry, a little squished. But that's what we're looking for, is that combo. If we don't have those two different things, it is not ionic. All right, and then hopefully, pretty obvious when we're thinking about particles, the particle that makes this one is ions. The bond or the force is an ionic bond. Questions, concerns, or comments? Cool. Right, the third and fourth one are tricky because they're very similar to each other, and you're gonna have to read other bits of the question to help give you guys hints on which one it is. So, I wonder if I should start on any page. I will start over here. All right, option number 3 is covalent molecular. And I'm gonna start another page so we can kind of see them side by side, which is covalent networks. So both of these have the word covalent in there, which is going to be an important thing. Now, first thing is that with the covalent molecular and with their covalent networks, you are looking for things that have nonmetals. So you're looking for nonmetals. So if you guys remember the examples that I gave you for the covalent molecular, you had H2O, you had CO2, and then for the covalent networks, what did I give you? Graphite, and I gave you quartz. So if we were to look at the periodic table, we see that there's carbon, there's hydrogen, there's silicon, and when you look over there, oxygen, silicon is kind of in between the two. Carbon, hydrogen I think actually should go with the nonmetals, but they do different things depending on the periodic table. Yeah. But what we're looking for is stuff that are nonmetals. Now, these guys, you're going to have to probably read the rest of the question to help you figure out which one's which. This one here, you notice how these guys are liquid and gas, and these here are solids. So with the covalent molecular, you are looking for nonmetals, and the hint to try to find them is you're looking for things with low boiling point. So read the rest of the question. Whoopsie. See what has a low boiling point. That's the way I would suggest you find it. These covalent networks, the hint to how to find them is, again, read the question. Look for what has a high boiling point or melting point. And I'm just going to abbreviate that BPMP. All right. We good? Can I show you some more? Can I move it? Nope. I can wait. Don't worry. What time does this class finish? Just want to make sure. I think it's 25. Yeah, it's 25. All right, keep going. So, like I said, we see that we knew what copper was. We knew that one was going to be a metal. We know the particle that makes it up is atoms. And we know the attractive forces is a metallic bond. Now, we have oxygen and we have graphite. Both of these are nonmetals. In this case, we are talking about the solids. They're all in the solid state. And what I'm trying to figure out is which one is the covalent network and which one's the covalent molecular. It is very unlikely in these questions they will give you two of the same because they want you to compare and contrast. So, like I said, we're going to have to read the rest of the question to find hints. I'm just going to grab a marker. So, this one's talking about copper. Copper is used for electrical wiring and rockets due to its ability to conduct electricity and be stretched into wire is ductile. So you see they're giving you information that can be hints to help you classify. But we already figured out what copper is. So let's figure out the other two. It says liquid oxygen, L, is stored in an oxygen tank of the rocket. The tank is made up of carbon composite, which contains graphite, which is a solid. Under atmospheric pressure, oxygen turns into a liquid at negative 183 degrees Celsius. So what that tells me is that, at room temperature, that's going to be a gas. Yeah? And not a solid. Whereas graphite needs to be heated to 3,600 degrees Celsius for it to go from a solid to a gas. So from that information there, I can figure out that the oxygen is my covalent molecular, because that has a low boiling point, and my graphite is my covalent network because it has a high melting point. You see how I did that? Read the rest of the question. It's a big, big hint. All right, keep going. All right. Covalent moleculars. Again, we need to think about the particle. The particle in this case are molecules, which makes sense because you're calling it covalent molecular. And then the force holding it together are the intermolecular forces. We'll talk more about this when we break it down. Oops, just trying to make sure there's enough space you can see both of it. All right, covalent networks, however, their particle are atoms, and the force that holds these guys together are your covalent bonds. So I'll just highlight those so you guys can find them in our notes easily. So particle. Ooh, this is kind of dried out already. That's not impressive. Just bought these. Just highlighting them so we can classify them. There you go. Force. There we go. So if I was to finish filling this in here, particle type would be molecule. This would be intermolecular. And then this would be atoms as well, and this would be covalent. If you can't classify them, it's going to snowball, and the rest of the answer is going to struggle. Questions, concerns, comments? No? All right, trying to think. So, when we are doing this topic, in fact, I'm only going to talk about these first two, and then we're going to stop there, and then we will pick up term 3, the covalent molecular and the covalent networks. We're actually going to do that later. The reason why is because this covalent molecular ties in with this question here, and then this covalent network, I can tie it into an internal. That's optional. Okay, so we're just going to do these first two, and these two are probably the easiest to understand anyway. All right, any questions? All right, we got about 10 minutes left. There is a Kahoot that we can play to help you guys with classifying. Yes. Yeah, I'm happy for you guys to go on your phone for Kahoot. Sound good?